We're live.
Okay, great. This is a demo of our Workbench tool, which is very much like an AI-assisted IDE that developers use, except this is for actuaries, underwriters, and other people in the reinsurance industry. And we're going to demo this tool by playing out a scene that we have played out many, many times in real life, where we get a reinsurance submission, we read it, analyze it, gather the data, analyze the data, model it, then price the structure, which often takes us at least several weeks at the fastest. But we're going to show how we do this in Workbench using a bunch of AI agents that we'll introduce as we play out the scene. And so we'll start the scene. Mark and I are going to work on this. Mark will be the data scientist or actuary working on it. I'll play the underwriter or the portfolio manager pricing it. Okay, so Mark, great. So we've gotten new data for this MGA. Let's start a new project to work on this, and I will load up the data for this in the project. Okay, I see the project on my end, and I'm going to load in. The first thing I'm going to load in is the reinsurance submission exec summary, and also provide the one from last year so that we can look at the difference or what's changed. And so you can see that I've loaded on those files. This is a multiplayer environment. Mark and I are in the same interface. And now I'm going to ask Patterson, which is our agent that compares documents. And so let's see, I call Patterson and I would say, please take the reinsurance submission documents, compare 2024 to 2023, and summarize any material differences in the narratives. And I'm going to submit this prompt. And we should see Patterson working on things. And
there's our summary.
Okay.
Top so you can see what's going on.
All right, so okay, it's given a premium volume portfolio mix, and the only thing to highlight here is that prospectors component. Obviously, we've made up names of these MGAs and the underwriting groups. The prospectors portion of the portfolio is going down. The other portions are staying about the same. They've indicated they're changing TPA so that all of these three sub-portfolios are now managed by the same TPA. They've indicated that they expect the loss ratio to go up, so they're expecting some deteriorating performance. That's interesting that the MGA is saying this. Usually they say it's going to get better and better. Let's keep scrolling down on here and take a look at this. And okay, so everything else is basically, other than the shift on prospectors, everything else is pretty much the same. So is there anything more there below for okay, that's great. So let's, you have the data, Mark. Why don't we start looking at the data?
Yep, I'll go ahead and load up the data that we received. And so as you can kind of tell from the summary and the reinsurance submission, this deal that we're evaluating is actually three separate products that are managed separately that are all obtaining reinsurance simultaneously. And so the data likewise is going to show each of those three products separately. So I'll go ahead and ask Bermuda.
Actually, not three products, just to be clear, three market segments for the same workers' comp product.
Right. And so I'll go ahead and ask Bermuda to load up the data. Bermuda is our general purpose agent for manipulating and visualizing loss triangle data. So it is going, and pretty soon we're going to get the message that yes, it is ready to go. It's all loaded up into the system. So let's start by just taking a look at the data. I will ask it to visualize just the right edge of the data in the triangle. And so the right edge is just the most recent premium and loss experience that we have for each of these subsegments of the portfolio. And we can take a look at the plot right here. Excellent. So we got three plots here. one for each of those subsegments of the portfolio. And the gray bars here represent earned premium in each accident quarter. It looks like the lumberjack program has been growing. Underwriter had been growing too, but that growth has leveled off recently. And then we can also see the blue and the orange dots here are paid and incurred losses respectively. And we can see here that the loss ratios have been going down in recent quarters. That's not necessarily because the business has been turning around. That's because these are undeveloped figures, and it does not include IBNR or anything else. And so, this is just reflecting the fact that the data is relatively green at this point. So then, if we scroll over to the right, we'll also see the data on prospectors, and here we see that there's really not a lot of history here. And
okay, so we only have a couple of years of history. So, okay, so I think Mark, I feel more comfortable if we, rather than modeling just their portfolio, let's also include a proxy portfolio of another MGA that also has similar business to the prospector business, and I'm gonna get that data and I'm gonna load it into. If you go to project files, I'm gonna load that, and you should see this proxy triangle show up. That's great.
And I will ask
Okay.
Bermuda to attach that to our project as a proxy development data set. So when we actually get ready to do some modeling, we'll have access to that data. And that is running right now, and we have our response. Excellent. Okay.
So what Bermuda has now incorporated this data specifically for prospectors.
Mm-hmm. The last thing we'll do is we'll take a quick little look at the mountain plot of the data, and so Bermuda is going to render that. And the mountain plot here doesn't show just the most recent diagonal; it shows the entire loss triangle for each of these three subsegments of the portfolio. And this is a great diagnostic tool for seeing if there's anything unusual going on inside the loss development patterns that might violate some of the assumptions that we might be making in terms of modeling. And we should see that here in just a second.
I see it says the mountain plot right there.
Yep, I see it right here.
In the project file.
Yep, and we should have access to this artifact any second now.
And so, set it up in the project file, and it will create a separate tab to show that chart.
Yes. Aha, there it is. Excellent. And so looking here, I don't see anything particularly unusual in terms of development. I don't see any cases where all of a sudden the lines aren't running in parallel or anything like that. Sorry, in terms of interpretation here, we still have accident quarters here on the x-axis, and we've got loss ratios on the y-axis, but now everything is stacked up where successive development lags are successive lines. And so what should happen is that the loss ratio should go up over time as the losses develop, but eventually they should asymptote out, and you wind up closer and closer together. You can see where they're converging to ultimate.
So it just shows unlike the right edge plot, this shows the development over time.
Exactly, yeah. And I don't see anything unusual here that would violate the assumptions of the development models that we're using. So we're good to go there. So now we can go ahead and turn our attention to loss modeling. And so we've got an agent called Carnac that will help us with the loss modeling, but this isn't some entire revolution in our methodology. This is still a similar methodology and pricing philosophy to what we've been using for the past few years. And so what we can do is, instead of just starting from scratch, we can actually just ask Carnac to pull up the structure of the analysis that we did last year when we looked at this, and we can use that as a starting point for our analysis. So I'll just go ahead and ask Carnac to show us the structure that we used last year, and here it is, and excellent. So it looks like we did.
So you mean these are the parameters that you used for modeling last year?
Yes, and you can see here that we did actually model each of these subsegments separately last year, and I think we should do the same thing this year. It looks like last year we were using the Bondi model for tail development, and the results of the back test that we did last year showed actually that the Clark model does better on the tail, so we should switch over to using the Clark model there. The other thing that we ought to do is that these cutoffs are, the points where we switch from using just, sort of traditional chain ladder to using tail models. But we've got an extra year of data now, so we might as well push the tail cutoff another 6 months out into the future. So we should just add 6 months to all these tail cutoffs. So I'll go ahead and ask Carnac to do both of those things. I'll ask it to switch over to the Clark model and also add 6 months to all the tail cutoffs. And there it goes.
Okay, so great. So Carnac is an agent specifically focused on doing stochastic loss modeling using various methods. And it knows that as you give it parameters, how to parameterize those models and run the appropriate models.
Yep, and now we can just go ahead and ask it to show what the new setup looks like to make sure that it was applied correctly.
And I saw that for the prospectors, it had blended in the proxy data as well. You can see that
Yeah, you
here.
can see that right there. It's using the proxy data along with the prospectors. Now it's using Clark, and now these are 6 months later on all the cutoffs. Excellent. This means I think I'm comfortable with this. Let's just go ahead and run the analysis and see what we can see.
So it's just confirming what parameters we want to use. And now you're asking it to actually run the stochastic models.
Exactly.
Which I imagine will take a little bit of time, right? Because there's like 3 different models that are being combined for 3 different parts of the portfolio.
Not terribly long, especially since everything is running in parallel on the back end. But everything is all ready now. So let's just go ahead and take a look. And the first thing we'll take a look at is just what the losses on the historical data developed to ultimate look like. So I'm going to ask Carnac to show the mountain plot, except now instead of just showing the historical data, it's also going to show our ultimate forecasts. So I'm asking, please show the mountain plots with the ultimate ratios.
While that's happening, Mark, can you show under arguments and results what that what's happening there?
So, and the reason there's no arguments here is because actually it's doing a lot of detailed construction on the back end in order to generate these configuration files.
I see.
Yeah. But if we go into here, excellent. This is exactly what we expect to see. So now we still see the mountain plot with the original data here in the orange color, and then the blue actually shows our developed ultimate results. And so, as expected, it looks like prospectors' performance is pretty flat. It looks like the underwriters' performance in recent years might be getting a little bit worse in terms of loss ratios. But we can also see that uncertainty is higher in the most recent accident periods, which makes sense because we've got less information. There's more uncertainty about where the ultimate's going to be. The other thing we can see is that we're showing development results separately on both a paid and a reported basis. And the nice thing that we see is that we're getting approximately the same answer, numbers that are in the same ballpark for both of these. So, underwriter reported is right over here, whereas underwriter paid is over here, and the ultimate losses wind up in the same ballpark. So if we're getting the same number from 2 different models, from 2 different methods, with 2 different sets of input data, that gives us confidence in our results.
And what's the combined? Can we see something on a combined basis?
Well, let's just ask directly. So yeah, this is not a volume weighted to get us to a volume weighted ultimate loss ratio. Let's just ask Carnac what the ultimate forecasted loss ratio is, the mean. And Carnac is thinking for a second. Of course, behind the scenes, it's not just generating a single loss ratio; it's actually generating an entire distribution. And so,
can we? How about the arguments and results on those artifacts while Carnac is running?
Yep. And you can see here it is. Yep. So it is passing in the identifiers to the data sets that contain the ultimate forecasted plots, and then it will go ahead and generate the plots there.
So it's a JSON structure that is being passed back and forth there.
Yep. And while it's working on the mean, I'll go ahead and also ask it for a histogram of the loss ratios, so we can actually see the full distribution of the 10,000 simulated ultimate loss ratios.
Okay, 73.7, so a 74 loss ratio.
Yep, and I'll just go ahead and ask it to download and show the plot.
And this is all Carnac doing it, right?
Yep.
All right. So
it is now
mean is 73.7. Okay, so we see a plot of the distribution. Okay, so this looks like the likelihood above 120 or something like that is very low, which will end up being the reinsurance limit then. But I can see, okay, this is useful. So I'd like to use this entire stochastic forecast so that I can create a stochastic performance, financial performance here. Okay, so now that we have the results, why don't we first look at how we price this last year so that I have a starting point for this. And so we loaded on the demo contract, and you're going to use Quill to look at those terms.
Yep. So
right?
go ahead and ask Yep, I'll go ahead and ask Quill to go ahead and read through last year's contract and extract the key terms. And so that's what I'm doing right there. Demo contract.pdf. That is the file that we're interested in. And there it goes. And
Okay.
there it goes. It's thinking, and we should have results in just a few seconds.
All right. So Quill is the agent that specifically looks at contracts, extracts out the key terms, particularly the numerical terms, which are often difficult to extract out the nuances of the underlying math here. And so the key thing I'm looking for is what the reinsurance premium or the ceding commission was last year. And okay, so the reinsurance, the ceding commission was 32.5, reinsurance premium is 67.5. Oh, and the aggregate limit, yeah. So the loss ratio is lower because it was limited to 80%. They had a layer above it that they were buying separately, but this year the aggregate limit is 120%. So that's why the gross loss ratio is higher. So, okay, I think now we're ready, Mark, to price this. So let's use Tully to price it. And here are the deal terms that I'd like to price. Let's do a 20% quota share, price to a 97% combined ratio, and add 2% brokerage fee, add 1% FET, add a profit sharing that's 8-point slide and spans the mean. Use the 120% aggregate loss ratio limit. Assume the collateral required is 120% of reserves, and for investment return, use the 3-year risk-free rate plus 1%. So let's give all of those terms to Tully to price.
All right, there's all of that, and we'll have Tully go. So while Tully's going to take a little while to do its thing, but that's because behind the scenes, it is not just using some basic rules of thumb in order to figure out what the investor impact is. Yep, that is correct.
Well, that was pretty quick. Okay, so that's a summary of the terms.
Right. And now we're going to have Tully run the deal model and show results. This is the part that's
okay. So it's like Carnac, where when we're running models, we specify the parameters, and the agent spits back the make sure it understands those parameters before it runs those models, and that's what it's done here.
Yep.
So that's great. So we make sure that it's understood what we're saying there. And so now it's running a stochastic model that will give me IRR and the mean IRR and other performance metrics.
Yeah, so behind the scenes, what it's doing is it not only has 10,000 simulated ultimate loss ratios, it's got 10,000 separate, internally consistent and coherent paths of cash flows. That includes earned premium, that includes loss payments, that includes actuarial adjustments to aggregate loss reserves in response to new information that they see from paid losses. And so, given all that context and given the deal terms, translating that into investor returns is actually just a matter of some pretty simple arithmetic, because it can just apply the contract terms, apply the collateral terms, so on and so forth, in response to the simulated data that we think we might see on this particular transaction, and we can actually get the performance. So even though it's a collateralized deal and structuring is a little bit more complicated and figuring out investor impact is still a little bit more complicated, our tools handle it natively. And we should have our results any second now. Oh, here it goes. Excellent.
So this is live. This is actual data, actual transaction, in the actual deal model terms.
Yep.
So okay, so the mean IRR is 14%, which is just slightly lower than what I wanted. I wanted to price it at least 15% return. But the probability of loss is low. That's great. It's less than 10%. And the invested capital is $21 million, which is a little bit high for this transaction. I'd like to price slightly different terms. So let me suggest that we, and this is, again, I guess we can ask Tully to do this, right? To update the deal terms to decrease the investment return to just risk-free, increase the reinsurance limit to 140%, and reduce the ceding commission to 18%.
All right, I'll ask Tully to do all that. And we should get confirmation pretty quickly on that. Yes, it
Okay,
is.
so it's understood. Okay, great. So, okay, so it's going to take another 30 seconds to run this model. After it's done running.
Yeah, when we pick up, you can.
Okay, how about this?
Yeah.
Mark, while it's running, can you just show what Tully's argument and results are when it ran it last time?
Yeah, so this actually shows the detailed structure that we're using, broken down. Like, this is the actual the before and after of the deal structures in all its glorious detail. This is actually the JSON that's getting passed back to the engine that does the deal modeling. And so if you want to inspect anything in detail, oh, it's done.
Oh, it's done. Okay, so great. The IRR is above 15, which is what I had hoped, because there were two offsetting dynamics here. The invested capital is also lower. It's like 15 million. Probability of loss is a little bit higher, but still around 10%. So I'm good with these terms. So I think I have enough information now to Mark to negotiate terms with the MGA. So that's the end of our scene. And so there are a bunch of things to highlight. First of all of this was real transaction, real data that we used in real models. We've just anonymized the names for confidentiality. You can see that this Workbench is a multiplayer interface. So Mark and I are chatting in the same interface. We're both able to load on files. We find this much more effective way of working rather than Mark does his thing and then he hands it over and then I do my thing. There's a richer dialogue and understanding of the data and the modeling. The other thing, as I mentioned at the beginning, is that we're using an interface that looks very much like AI assisted ID, where on the left we have a bunch of different projects and agents. On the right, we have various tabs for the chat interface and some tables and things that the agents provide. And in the middle is really the work area where it's creating artifacts like charts and other things. It shows the project files. We're also recording the activity so that it maintains an audit log. There's a place for notes where Mark and I can capture some more notes, and this is all stored with this project. This product is still in development, but we thought it'd be useful to show a demo of this at this Actuarial conference. So thank you all. Okay.